Namaskar, Jai Hind, Jai Bharat, and welcome to Dev Talks. This is Aadi Achint. China flew a fighter aircraft, allegedly a sixth generation aircraft, और बहुत narratives. The entire bloody country went up in flames, literally to say कि भाई हम क्या कर रहे हैं, हम सो रहे हैं, which to an extent may be correct as well. But Chinese sixth generation aircraft पे पहले तो क्या हमको should we actually agree that it's a sixth generation aircraft just because the Chinese are saying it? Secondly, what should India do? These are two big questions that everybody is going to ask. HAL, DRDO को तो खड़ा होके कुछ ना कुछ करना पड़ेगा, and that is something that we know. They will have to stand up and do stuff. But are they at the moment, or are we looking at HAL and DRDO from the lens of history? Let's try and find out. We have with us Saurav Jha ji. Namaskar, sir. Thank you so much. Welcome
Glad
back
to be here. Thank you for bringing me on board again, Aadi.
Tell me, sir, was that a sixth generation aircraft?
See, the term sixth generation is itself not very well defined at the moment, so to speak. Okay, the whole talk of a sixth generation fighter actually begins with the next generation air demonstrator program of the United States, right? And the FAXX program of the US Navy and the NGAD for the USAF. Now, to be clear, the J-36, the Chengdu J-36 you saw the other day, and also the other one that they unveiled, the JXDX from Shenyang, which is like Chengdu's main rival, but both are under the umbrella of the same AVIC corporation, AVIC of China. You know, they have put all the various design houses and older PSUs, aerospace PSUs, under a single umbrella. On the military side, there's another umbrella corporation, obviously, on the civilian side, and there's one for aero engines as well. Right? That's the Chinese setup, broadly speaking.
This is the FAXX.
This is the FAXX. Yeah, it is nothing. It is the J-36 is not this. Okay, let's be clear about that. In any case, the term, even if you talk about the FAXX or the NGAD, the term sixth generation is used fast and loose and is not well defined. Broadly speaking, see, when you say something is of a higher generation, what do you mean? That it represents a major, significant jump in capabilities. So when you went from fourth generation to fifth generation, you talked about a fifth generation fighter having stealth, having super cruise, super maneuverability, sensor fusion, giving it a serious operational advantage, right? Now, the J-36 from Chengdu that you saw the other day, it is not designed to be, it is not a fighter anyway, okay? It's not a fighter. It is a three-engined monster which is designed for particular roles. It is definitely an advanced aircraft. It is an advanced platform. It is a step beyond fifth generation in certain ways. For instance, because of you would have seen there are two side arrays on it, very large side arrays. It will have a very large main radar also. It definitely has advanced networking capabilities. It has been designed to operate in the next generation advanced networking scenario, right? Where you tie in with a number of off-board sensors and via satellite comms, and also via other kinds of data links, right? So in that sense, it also will carry a much larger weapons payload than, say, the J-20. But it is not a sixth generation fighter per se. It is not a fighter anyway, okay? It can be called a cruiser in some sense, because its main roles, given what it is, will be standoff strike and standoff air-to-air combat. Okay, it has been designed in a way, if you look at what it is, it has been designed in a way with three engines, and I'll come to why it has three engines, and that also is another reason why it's definitely not sixth generation. Okay, so no, not because it has three engines, because of the fact that it requires three engines. Okay, I'll come to that. So the point is that this thing that you see over here, if I can't use the cursor, but yeah, if you can move the cursor, as you can see that it has heavy duty main landing gear, okay, tandem main landing gear, and it has a heavy duty nose wheel as well, right? So all of it basically amounts to this being a rather large and heavy aircraft. It's a cruiser, it's not really, but it's not a bomber either, okay? It's not just a regional bomber either. It's something of a hybrid between a regional bomber and a cruising aircraft at high altitude. It has these typical double delta wings, which you see on the Draken, on the Saab Draken you had seen at one point. That's an old Swedish fighter jet. But this double this double delta, again, I'm not an aerospace engineer, I might be considered an aerospace geek, okay, but this the double delta that you see on it is definitely something that is good for, relatively speaking, high Mach numbers like Mach 1.8 and all, as are the intakes on it, the side intakes, which are called caret intakes. For those who want to know, this is the same kind of intake you have on the F-22, right? So these are good for high Mach numbers, Mach regimes also in certain, for certain regimes. So this thing will fly fast. It's been designed to fly fast, but of course it has a dorsal intake also on the top. If you can show one image,
Yeah,
there's
I'll
a,
just show you
yeah,
one image from the top as well.
yeah. That is that is what is called a DSI intake. Okay,
Yeah,
which you will see,
continue,
on the
continue. I'll just find an image.
J20 also. Okay, anyway, so there are three engines, there are three inlets, okay, intakes, three intakes, two on the side and one on the top of the fuselage as a dorsal intake, on the midline. Okay, now the point is that that of course that intake is usually optimized for different regimes from the two caret intakes that you see. So this led to a lot of speculation about whether the middle engine is a different kind of engine to the two other engines, but that is not the case. From all accounts, from what I have seen from Chinese sources, imagery, our own analysis, yeah, that's the dorsal intake. This thing has three WS-15 engines, which is sometimes codenamed as EMEI. Okay, so this is their best engine, so to speak, best indigenous engine. But it is not even a fifth generation engine. Forget about it being a sixth generation engine. Okay, it is very much a fourth generation engine in terms of its efficiency, in terms of its specific fuel consumption, which itself is dependent on its overall pressure ratio, which is also that of a fourth generation engine in terms of the bypass ratio. I won't bore our viewers with details. Suffice it to say, it is not a fifth generation engine. It has nowhere near the kind of efficiency that a fifth generation engine has to have, and it definitely does not have the parts life of a fifth generation engine either. Okay, so for a true sixth generation fighter, you need a proper sixth generation engine, which will have much greater efficiency and will also be what is called a variable cycle engine. Okay, it
What
will
does that
be
mean?
okay. A variable cycle engine, usually when you talk about, if you look at the WS-15, it is a what is called a low bypass turbofan engine. Okay, there is a fan before the compressor. Before the compressor section begins, there is actually a large fan. So a whole bunch of the incoming stream is basically moved in by the fan through the cold section of the engine, and some of it from the fan goes to the compressor into the hot section of the engine, into the afterburn, into the, sorry, not afterburner, into the combustion chamber, the turbine section basically. Okay, so in any modern turbofan engine, or in any turbofan engine, you have two streams. You have the cold stream and you have the hot stream. Now, in a variable cycle engine of the kind that is considered necessary for the sixth generation fighter, you need something what is called a three-stream engine with adaptive bypass. The amount of air that flows through the cold stream is called the bypass, and the bypass ratio for a low bypass turbofan is around, depending on what generation of engine it is definitely below 0.4. Okay, most of it is sent through the core of the engines only, the hot core, the hot section of the engine. So anyway, in a three stream engine, some of the air you can increase the amount of air that you send through the hot section at times, or decrease it. So it has variable bypass. Till a fifth generation engine, the amount of bypass is a fixed matter. The bypass ratio, as it were, is a fixed matter. Okay, how much goes through the, how much goes through the center of the, and how much goes through the cold areas. Okay, that's the fan right at in up front. Then you have the compressor, turbines. Then you have the combustion chamber sections. Then you have again a set of again a turbine section. Ah, I mean, you have the turbine sections at the back only. The compressor sections are forward.
Yeah.
You have the turbine sections after the spool. So that is what you see. When after the combustion, the turbine sections come after the combustion chambers. Anyway, so you have fan, compressor, combustion chamber, turbine section, then afterburner, then exhaust. And in the case of the bypass, what is happening in a turbofan engine, some of the air never goes through the compressor section and the combustion chamber and the turbine section. It just goes from the outside, within the engine, but it just goes through, and then the two streams mix and then they come out. Okay, at the end. So through the exhaust right at the end. So basically what happens is, in a variable cycle engine of the variety that you need for a so-called sixth generation fighter or a sixth generation engine, you can vary the amount of air that is bypassed or is sent through the hot section of the engine ultimately. That is the kind of variable, that is a variable cycle engine. Now, the thing about the variable cycle engine is it is very difficult to do. It is definitely it is at the pinnacle of jet engine technology today, and it is also at the pinnacle of manufacturing technology because of all that goes into it in terms of forging capability, casting capability, ceramic matrix composites, because you will not be able to make do with super alloys only in the case of, however advanced, in the case of the sixth generation engine. Certain parts will have to be made of, even in the case of fifth generation engine, certain parts are made of ceramic matrix composites, but not the hottest parts. In the case of a sixth generation engine, some of the more hotter parts will be made from ceramic matrix composites. Carbon, silicon carbide, silicon carbide, silicon carbide. These are all ceramic matrix composite types. Okay. What type you choose depends on what kind of manufacturing technology you have, what kind desirable characteristics, all that.
What do you want actually?
Yeah. So Chinese are nowhere close to the United States in this realm. They are not even close to the Russians actually. And the United States is the world leader. The French come after that, the Russians after that, the Chinese behind that. Okay. So the best that they have right now is those WS-15 engines. That is also to their credit that they have that engine. That's a engine that generates 180 kilonewton of afterburner thrust. So it is a pretty decent fourth generation engine in terms of its overall, cardinal performance. But of course, it has nowhere near the reliability of an equivalent American jet engine, right? Or in terms of generation, I mean, a F414 is far more reliable than that WS15. Although F414 has only about half the maximum thrust of that WS15, but it's highly reliable, extremely reliable. And so the point I'm trying to make is the Chinese have been working assiduously, but they are still not at the sixth generation level. Actually, no one is. Okay, even America is not really at the sixth generation level, although America has run the sixth generation engine sixth generation engine programs for a long time, starting with what was called Advent. Okay, from the Advent program. So they have been working. So that gave rise to engines from both Pratt Whitney and from GE, like the XA100, XA101. Those were demonstrators that came later under programs like AETD and AETP. Anyway, let's not get into all that. Bottom line is the Chinese don't have a sixth generation engine. They're working on a fifth generation engine, which they may master in the course of this decade. But of course, it will not be anything like a Western fifth generation engine in terms of reliability, even by 2030. Okay. In performance overall, because see, you must have seen those reports, right? Some of their flankers, some of the copied flankers, as in, J11s and late model J11s also have had to fly back to base from time to time because of engines failing, right? So if you talk about total technical life of those Chinese engines, it's going to be considerably lower, even if they are supposedly of the same generation as a Western engine. So you are not going to have anywhere near a sixth generation fighter with the kind of engines the Chinese have, because the sixth generation fighter, the power consumption is very great, and you have to reliably supply it. Okay, during the course of an operation.
But may I stop you here? Doesn't the sixth generation also mean the incorporation of Ramjets?
Not necessarily. You see, if you want that is another kind of variable cycle engine. It would be. If you can have a turbine-based combined cycle engine, that's also a variable cycle.
You had it in the SR-71s.
Yeah, it used to transition into ramjet mode. Okay, there was this was done. I mean, the experiments were also done. The integral rocket ramjet kind of scheme was also is also something that has been explored in the past. But no, it doesn't have to be. It usually has to be a variable cycle engine of the kind I described. A 3-stream variable cycle engine. Because what you will do is, when you want, what for a 6th generation engine, what do you want? You want both the ability to super cruise as well as the ability to fly at very fast, very high velocity, as well as be able to loiter over the target area or near the target area. You cannot do that with the current kind of engines. Okay, you just can't. You need something like that 3-stream variable cycle engine, where you will move from one kind of bypass ratio to another depending on what you want. Right? When you want high speed, you will push more air through the core of the engine, right, to generate more thrust. That way, to generate, to generate greater sort of impulse. Or you will move it, or you will move, or you will, when you want to loiter, then you will increase the bypass ratio. Like if you look at civilian airliners, they have high bypass turbofans mostly, right? Because their agenda is not very high speed. Their agenda is endurance at a certain subsonic Mach number. Right? Mach 0.7, 0.8, that is what they fly at. So some of them, of course, can fly faster than that also. But so like a cruise missile also. A cruise missile, usually a subsonic cruise missile, flies at Mach 0.7, 0.8. Okay. Not that you use a high bypass turbofan on a subsonic cruise missile. You don't. You use a low bypass turbofan only. Yeah, but the point I'm trying to make is that, so it can alter the kind of stream, the stream on the engine itself, to give the desired flight profile characteristics. That is basically what I'm trying to say. That is not something you can do with a 4th generation engine, obviously. Okay, you can't even do it with a 5th generation engine per se. 5th generation engine, what you do is you have much higher thrust to weight ratio. It has to be of the order of at least over 10 and 12 to 12. Now this WS15, you can claim that it sort of gives you 10:1 thrust to weight ratio, but that depends on the loadout and all those things. Maybe in clean configuration it gives you better, whatever. But anyway, but the point is that 5th generation engine, you play on efficiency, a lot more efficiency, thrust to weight ratio. The engine itself doesn't take a lot of weight. Okay, the engine itself does not take up that much space as one would imagine for a. See, if you wanted an older generation engine to provide the same kind of thrust as a later generation engine, it would have had to have a bigger inlet to allow for more air to come through, right? Because you would have generated that amount of thrust by moving more air through it. But here you do it through efficiency gains. So this goes through. So you get an engine, and the 5th generation engine will also cater to lower infrared profile, lower aural profile, in terms of engine noise, lower radio frequency stealth, also all those things. So in that sense also, dropping 3 WS15s into a stealthy platform does not make it a 6th generation fighter. Okay, it just does not. It just does not work like that. Granted, it's an advanced design, advanced platform. Okay, but it is also something that has built upon the J20 quite clearly. It has the same kind of canted plane surfaces that the J20 has, and it has 6 what are called platform edge alignments. Okay, which is basically stealth shaping, and it's quite clear that the J20 has inspired. The work on the J20 has inspired the J36, the sort of layout you have for the J36. And so, and I can bet my bottom dollar that there are, or rather bottom rupee, that there are a number of components that are common to both the J20S and the J36. I'm making this point because this will be important. Okay, there's a lot of commonality in terms of parts and components between these two different fighters, and they have been developed by Chengdu, right? Having said all that, yes, the J36 is a step above in the sense that it brings wideband stealth. Okay, it has no vertical fins, it has no vertical stabilizers. So in that sense, it has all aspect stealth, compared greater all aspect stealth obviously, and all aspect stealth rather, which the J20S really doesn't have, compared to previous fighters from Chengdu Aviation Corporation. It definitely will have better electronic warfare systems. It'll have a better electro optical targeting system. You will see there are two large optical windows towards towards the front portion of the aircraft. I mean, towards the nose, closer to the nose. It also has two large side arrays. Both these things will be used both for A2G and A2A as well. Both will be used. Okay. So you have all these things, but because all of these things also require a lot of power and you don't have a commensurate engine, you have dropped in three engines in there. Okay. And to make sure that the third engine is not really a liability in terms of weight, but it is somewhat of a liability. You have to pull along another large engine as well. Yes, it is generating power, but it is also adding to the weight of the aircraft. So you have dropped in your best engines over there, right? The best engines that they have right now, the WS-15, they've dropped three of those in there to cater to the higher power requirements. And the power requirements for a true sixth generation fighter, if we can call something that, are quite high, especially if you try to put in, directed energy weapons for shooting down missiles that might be coming at you. Shooting down as in by frying their electronics mostly, or by blinding their optical sensors, imaging infrared sensor, if it is a close range, if it's a within visual range sort of missile, or just use laser ablative shock, but I think that is still a distance away. Anyway, so the point is that I don't think this has any directed energy weapons at the moment, because even with those three engines, power management, while on paper, yes, you can generate enough power for a decent sized laser inside the aircraft. I'm sorry about that, but I don't think that is really the case at the moment. Having said that, yes, this thing may also represent certain improvements in their overall materials technology, stealth materials, stealth coating. It can be characterized as a 5.5 generation aircraft. It cannot be called, but even that with qualifiers, okay. It cannot be called a fighter. It's not a fighter. It's not designed to be a fighter anyway. See, it has these on the. If you show me one of the pictures again, if you can just see the pictures.
Sure. 1 second. Yeah. Please continue. I'll just put it.
Yeah. So the thing is that, see, it has leading edge. It has these 5 control segments, aerodynamic control segments on both of those large double delta wings. Okay, they go all the way up to the nose. Not to the nose. I mean up to the fuselage, and the ones at the end are the kind of things you see on the B2 and B21. Okay, those are like at the end. You have those split rudders, split rudder kind of scheme over here at the end. Those are called split rudders. Those have maximum authority when they are open, and those are not basically something you would want when you are flying in stealth mode, right?
Well,
you don't want.
It'll create a radar signature.
Yeah, obviously. So it will create a major radar return. So what do you do with that then when you're trying to super cruise and in a stealthy manner? Then you have to use differential thrust on those engines, from those engines. So if you look at the rear end of the aircraft, okay, you will see these movable trailing edge segments also in it. The trailing edge of the aircraft.
I have a better, clearer image, so I'll just put that up.
Yeah,
it's a beautiful, clear image. Then I can show a little better. Here we go. Here we have it.
Yeah. Let me see. Yeah, so there are movable trailing edges also at the back. So this is capable of thrust vectoring. Okay. Some thrust vectoring capabilities there on it. But even with those large, split rudders and thrust vectoring, etc., etc. Split drag rudders, as they are, split drag rudders, if you want to be exact. Okay. If you have those, even with that, you don't really get. This is not something designed for great basic fighter maneuvering, although it might be able to do some maneuvering definitely. This is designed to fly high and fast and also loiter. Okay. Okay, it's designed for all those things, and it has very large weapons base. It has two large weapon bays on the side and one large center and one very large internal weapons bay in the center. In fact, if you did not have a middle engine, this would have been even bigger. Okay, that sort of thing has taken up some of the space. So this is good enough to launch next generation air launch ballistic missiles, which are in development in China, right? They are in development in China, and this is good for launching something like the PL-17, definitely very long range air to air missile. It is good for launching the AKF-98A cruise missile also, which is a subsonic cruise missile like the Storm Shadow or the Scalp that we have for our own Rafales, okay, imported from France. So, and it will be able to dispense a whole bunch of loitering munitions also, which will have swarm capability. So this is definitely designed to fly in stealthily and fast into close to the target area, close as in relatively close, because it is at standoff distance only. It is not going to be used for bombing in that old way at all. So, and dispense these dispense a whole bunch of standoff munitions. Okay, say from 400 or 500 kilometers away, and in the case of air launch ballistic missiles, further away, much further away from there, and attack airfields and aircraft on the ground while they are parked. Obviously, it will have to tie in with a whole bunch of sensors to be able to do that effectively. It will also be in a position to hang around not very far from areas of interest and take long range BVR shots, at enemy AWACS, tankers, and even fighters with the PL-17, as we have seen in the Ukraine conflict. Many of the Ukrainian Air Force losses have come from basically R-37s, launched by either MiG-31s or Su-35s. So, in that sense, this is definitely a threat. It's a bigger problem than the J-20S is. Okay, the J-20S does not have the kind of payload capacity this thing has. It does not have the loiter capacity of this thing, and the J-20S, because it does not have the kind of range and endurance that this thing will have, okay, sees only limited deployment against India. I'm talking from the Indian perspective. Okay? You would have seen, Adi, in 2021, there was there were these Chinese media sources which came out with news about a J-20A deployment, I think, to Lhasa. And they had huge problems, okay, with the lube line freezing. I mean, the oil freezing.
The body, the stealth paint was flying off. Also,
stealth paint flying off. Yeah, the integrity of the stealth coatings was totally lost. Okay, now even if they have made some great advances since then, I'm not so sure that they'll be willing to risk all that in those high altitude areas. Okay, high altitude airfields. But problem with this damn thing is, I'm sorry, but I edit that in the final thing.
That's all right.
The problem with the J-36 is, and the J-36 is definitely more than just a common demonstrator, just a typical tech demonstrator. I'll come to that later. It is much more advanced than just a tech demonstrator. It is definitely a sort of advanced prototype, I would say, just like the J-20 was when it was first unveiled to the world in 2010. So when this thing attains full operational capability, although for the Chinese IOC, FOC also have different meanings, but say by the 2030s, when it is deployed against India, we will have a bit of a problem, because this will be able to take off from airfields in the Tarim Basin, right? And have significant loiter time close to areas of interest, close to places that we will have to defend, which they still don't have. Even if J-20s, they base them at Korla or Hotan or whatever, they don't get exactly what they want, because they don't have mutually supporting bases. That is one of their other problems in the Tibetan plateau and even in the Tarim Basin. But this thing sort of obviates that problem to a great degree. Okay. So in that sense, we need to be concerned about this. It is not sixth generation in that sense. In fact, if you go by the Chinese, yeah, if we say the J20 is the fifth generation and anything that comes after that will be called sixth generation, yes, then sixth generation. But no, if you go by the Chinese, by the way, in their lexicology and terminology, in their lexicon, the J20 is a fourth generation fighter. Okay, so to them, this is then their fifth generation fighter. Okay, because not fighter, fifth generation aircraft. Because as we've cleared, as we can see, it's not really a fighter, but it will be capable of both air to air and A to G, and is a serious threat. We cannot deny that, despite its limitations, because of limitations in Chinese jet engine technology. That is the main limitation that this thing faces. Actually, we are still. Yeah, go ahead.
No, now let's kind of switch to India, because there's a obvious threat, and you are a big proponent on Make in India, Atmanirbhar, and you've always said that let it take time, but do it well, and create something good within the country. I support that. Two questions. One, how do we do that? Two, what do we do for the Air Force?
Very interesting. So let me first point to something. The chase plane for the J-36, when it was unveiled, was a J-20S.
Yeah.
Okay. The chase plane for the J-20S was a J-10 when it was unveiled. A J-10, I think it was a J-10A only, if I remember. The chase plane for a J-10 was a MiG-19 copy by the Chinese.
Yeah.
Okay. Or was it a MiG-17 copy? Anyway, it was one of the very early Soviet design planes. So
no, it was a MiG-19, correct? You're right.
Okay,
it was a MiG-19.
Okay. It was a MiG-19 copy. So the point, but basically a J6. Okay. So the point I'm trying to make over here is, they have shown you what to do. They have gone from one thing to the other thing, and the time taken to go from one thing to the next thing is reducing all the time. Okay. This is exactly what you saw during the Cold War also from the United States and Russia, because they would not rest on their laurels when one project was done. They would sanction the next project. What happens is, and this is not just plain, incremental development. It's not. It's called spiral development in industrial terms. It is iterative in a sense, because you take the same supply chain and you upgrade it, you expand it obviously, but you upgrade it also. But you let your designers build on what they have built earlier, right? You let your designers and engineers build. You do not allow your human resources and your industrial supply chain to attrite. Who has allowed it to attrite? The answer, Europe has allowed it to attrite, right? The European aerospace project flew in 1986, the EAP, what it was called. If you remember the EAP, right? The EAP demonstrator, it first flew in 1986. So the experimental aircraft program, as it was called. So the EAP demonstrator.
In that way, even the what do you call the JS10, the JS series of engines was first, I think, 1982 or 1985 or 1987.
87, the first WS10A. Okay. So anyway, so what I was saying is that if you look at the EAP, right, the experimental aircraft project, it flew in 86, and the Typhoon was inducted in 2006 in the British Air Force.
Yeah, 30 years.
20 years, but anyway. Yeah, but the work began 30 years ago only. Okay. So the reason why we are trying to say, and then there were there was the replica project, BAE replica, which went nowhere, etc. Europe has done this to itself. Europe did not have follow-on projects. Today they are talking about FCAS in France and GCAP in Britain. And why do they have to go with others? Why does it have to be a pan-European project and even include the Japanese in it? Because they just don't have the manpower. They have allowed it all to attrite, because there's nothing that has followed on from the Typhoon really. Yeah. Okay. And another very significant point, the Europeans have been a great believer in this demonstrator, whereas the Chinese have followed the Americans and the Russians. They basically, if they are building something, it is a very advanced prototype, so to speak. if it is something that is next generation from their perspective. They're building an advanced prototype, in the sense that, not in the sense of it being advanced in terms of capability, no, in terms of it being advanced in terms of something that they're serious about production. Get what I'm saying? So when the J20, the first J20As, they were not that advanced in terms of capability. Okay, the J20S with the WS15 engine is far superior to that, I would say. But the prototype itself was a very advanced prototype. It was not a demonstrator that I just want to demonstrate this characteristic or that characteristic or something of that sort. It was something that was already advanced enough to basically enter production in another 5 or 6 years at the most. In fact, that all those times. So when you have a going concern in terms of a going aerospace sector, and which is constantly looking to innovate and bring in new designs and new platforms, that is a very different kind of scheme from one where you make something, then you think for 10 years whether you're going to induct this or not, then you order a few more, then you basically, the minimum order quantities are nonsense. Okay, 20, 10, like this is not how you run an aerospace sector. And then you say हमारे पास ये क्यों नहीं है और वो क्यों नहीं है अभी, ठीक है, ऐसे नहीं होता है. और एक चीज समझना चाहिए, viewers should understand this. The answer to this Chinese J36 is not to be found anywhere right now. ठीक है, कहीं भी नहीं है. The F-22 can be an answer, but F-22 will not be given to you. Okay? And even the F-22, because it was designed much earlier and production stopped in 2005, it needs to undergo a serial modernization. Okay? It has many old sensors and stuff like that. So, and old parts and components as well. Anyway, but that's another matter. I'm sure there will be a proper MLU of the F-22 by the Americans as an interim measure before they decide whether they need that NGAD or not. The US Navy will definitely go forward with FA-XX. So what I'm trying to say is, but Tejas is a reality today. Tejas Mark 1A is also a reality. Because Tejas Mark 1A was ordered in some significant number, a better number than in the past, you have a supply chain for it also. And with the third line in Nasik, okay, about to come online, you will be able to credibly produce 24 Tejas Mark 1A in a year, provided you have the engines for it. Okay. The big bottleneck right now is the fact that the GE FO04 IN20, which is the power plant for the Tejas Mark 1A, is not being supplied. I'll come to why I'm emphasizing this, because you know why. And the Lynn, Massachusetts factory was not producing anything for a long time. Now they are saying that production is restarted there, etc., because they were having trouble with their own supply chain. And of course, there might be other reasons also. But let's not go into that. Yeah, and that is another reason why you need Atmanirbharta, by the way. So, in fact, the main reason. So there lies the rub. Herein lies the rub. What is HAL doing at the moment? They're actually producing all the ordered airframes, by the way. They're keeping them ready, waiting for the engine. So they intend to stick to that 28-29 FY 28-29 timeline to complete the orders, as has been contracted by the IF. And they're going to deliver some of the aircraft with what are called category B engines. Okay? Reserve engines. And as you know, we have built a whole bunch of Mark 1s, not a whole bunch, just 40 Mark 1s. And we built a whole bunch of LSPs before that. We built a bunch of PVs also there. Many of them use the F404 IN20 rather than the F404 F2 J3, which is what we had used for the first TDs, by the way. Okay. So anyway, so what are you seeing over there? You are seeing engines that have been used for the test program and as reserve engines for the first lot of aircraft. You're going to deliver some of the Mark 1As with this. So what is the Achilles heel of India? The engine. Okay. So that is where we need to focus on big time. At the same time, we should not allow our design capability to attrite by saying कि हम तेजस Mark 1A के बाद Mark 2 से नहीं सीधा AMCA में जाएंगे. वैसा नहीं होता है. Especially for India, वो तो होगा ही नहीं. ठीक है. Tejas Mark 2 is not an incremental growth over the Tejas Mark 1A. Say, ठीक है. It has many new systems and it has many new parts and components. it will have only about 25 to 30% parts commonality with the Mark 1A, but it will have 70% parts commonality with the AMCA. Okay? It is going to be a proving cum certification ground for many things which will go into the AMCA.
The next,
just like, yeah,
so you
just
have
like
to take one, you can't kind of jump on the last ladder first. You have to kind of go.
You cannot, because agar aapne even if you design something, even if you design new subsystems which are better at this, that, whatever, who's going to produce it? Okay, it goes hand in hand. You need to have the supply chain ready as well. You need to upgrade the supply chain as well. And the supply chain will not upgrade itself unless it sees orders from your proving ground. And the Tejas Mark II in itself is a desirable quantity, is a desirable element. Because see, 2026, the last F-16s will be delivered to the United States Air Force. United States Air Force intends to keep the F-16 in service till 2070.
Yeah.
Okay. China is still producing J-10s. Still producing. Achha, there was great parts commonality between the J-10 and the early J-20s. Okay. There's parts commonality definitely between J-20 and J-36. And even with the JX-DX, that Shenyang demonstrator that you saw, which is more like a fighter, which we didn't get into, the other thing that the Chinese unveiled, even that has great parts commonality with the J-10 and J-20, even though it was from another company, but they leverage the same tier 1, tier 2, tier 3 suppliers in China, right? So they have some of their favorites because of Chinese politics, but mostly the same. So the point I'm trying to make over here is, it is an industrial effort. It is not a khajur that you can just pluck from a tree. It is a major industrial effort. It is a multi-year industrial effort, and you cannot import your way to meeting your very, very complex and large defense requirements. You just can't.
Long-term vision, I mean, short-term when I mean is about 10, 20, 30 years. But long-term, you kind of need to develop on your own.
Adi, I don't think even 20 years can be considered short-term anymore. Okay. So, and the other thing is, see, even in the short term, if you have your own platforms, you can upgrade to meet new challenges. Example, suppose the Pakistanis also get the PL-17 tomorrow. Okay. And you want to put on board something equivalent so that you don't lose the first shot advantage. Will you be able to integrate some next generation AIM 260 on your existing platforms? No. Either they will not agree, or even if they agree, it'll cost you an arm and leg to do it, right?
And probably some other geopolitical
problems as well. Yes. But if you have your own Tejas Mark II, you can integrate any number of weapons onto it. And especially if you have your own weapons, like the Astra Mark III.
Correct.
So in a no war, no peace scenario, something like the Tejas Mark II, which has 4.5 generation, 4.75 generation characteristics in terms of networking, sensor capability. In fact, it has very many 5th generation capabilities on it, right? Because it is a much later day plane using the electronics and avionics of today. In terms of avionics, India is close to the frontier in terms of avionics. India is obviously very far from the frontier in terms of propulsion capability, which are Achilles' heel.
Yeah.
So you have something which will be quite competitive in the regional environment. Why is it that the Chinese then will why do they continue to fly J8s and J87s and J10s? You cannot run an air.
They are still producing the J10s, by the way.
Yeah, that's what I said earlier.
And
so that's the
producing
point.
The J8s also, by the way.
So that's the thing. You need a mix in your Air Force, the so-called high, low, medium. It used to be a high-low mix. Now it's called a high, medium, low mix also in the Indian Air Force, at least. Yeah, okay. Yeah. Because you have a medium fighter apparently in the Rafale. Although it's not really a medium fighter, but whatever. But the thing is that this, you need a mix. You need a mix which is under your design control, so you can upgrade quickly to new threats, to add new capabilities. And the Tejas Mark II is an industrial and a technological bridge to the AMCA. A credible Tejas Mark II production run will mean that the time frames for the delivery of the AMCA will also go down, and the amount of time taken to develop the AMCA will also will go down, obviously, before that. The
Okay.
development cycle can be compressed, to use an Indian term. Indians use this term, right? The developmental cycle can be compressed if you with the Tejas Mark II, and it is going to fly next year. By the way, it will
Correct.
fly next year.
Yeah.
It is being hastened at the moment as we speak. It will fly next year. So the thing is that this is how you go. This is how the spiral development happens. So if you invest in the Tejas Mark II now, and you can start producing the Tejas AMCA, and you finish development of the AMCA in a compressed time frame, because a lot of the work has already been done through the Tejas Mark II, you can start producing the AMCA in large numbers by the 2035s, or by the 2036s. Okay, and that is when these things will be flying around in some kind of numbers already against you, besides the J20 in large, which will be there in larger numbers. But J20 will continue to have those payload and endurance limitations when taking off. Anything will have when taking off from high altitude air bases. Let me rephrase this. J20 will not be able to mitigate the payload and endurance limitations that the PLA faces, fighter fleet faces, when operating against India, because of the location of the air bases. But the J36 will be able to, because of what it is, right? So we'll have to be ready for that day. Now, to be ready for that day, the only way to be ready is not to have great fighters of your own. You will need counter stealth radars that can operate in high altitude areas in eastern Ladakh and other places. You will need greater networking. You will need many more, much greater satellite networking capability, which is the one place where they are leagues ahead of us, the Chinese, right? That also points to another thing. When China did not have all this, it came up with what something used to be called the assassin's mace, if you remember. The assassin's mace concept, where they would asymmetrically attack US strengths. One of the main strengths being American national technical means, right? Their satellite-based ISR capability, their communication satellites, basically blind them and not allow them to use next generation network warfare on the Chinese. And also what became A2AD systems to keep them further away. So we need to tank up on our rocket force also. See, we are a missile power. Why are we a missile power? Starting with the IGMDP, we have invested in this sector continuously. We have kept working on new projects, so much so that you are now seeing next generation hypersonic systems also.
Yeah.
Okay, we are not behind.
Which the Chinese don't have properly at the moment.
Well, they have also worked on very interesting things, but let's say that we are not behind anybody in that realm, really. We are not.
Yeah.
And you even invested in a hypersonic wind tunnel, which took 4 years to complete between 2016 and 20 for 412 crores. Same thing can be achieved with jet engines also. The time is to begin now. Without a jet engine, you are not a credible aerospace power, and you will always be crying and saying kuch import kar lete hain, which will not be an answer, because the enemy you're facing now has gone down a very different path. You're not facing Pakistan anymore, which is also dependent on the largesse of some third country. Koi F-16 de do, koi J-35 de do. Okay? That is not what we are faced with. We are faced with a country that is now the world's largest manufacturing power, which has the largest industrial estate in the world now. Okay? And which is leveraging that. So Make in India has to work on aerospace and engines in particular. See, the government understood that semiconductors is a major lacuna. They are working in a stepwise manner to address that. That also has a direct bearing on national security. Now is the time to address the jet engine problem. Where does jet engine development in India stand at the moment? Let me say it in a very concise manner. We have currently 4 jet engine programs, or rather, let's say 3 jet engine programs that are going to see production seeing production in a sense. One, they're already seeing limited series production. One is the Manik 1 small turbofan for the Nirbhay family of cruise missiles, also now called long range land attack cruise missile. The second type that you have is, of course, the ATGG, advanced turbo gas generator, that Azad engineering will make. That's another GP.
Correct.
That's for let's say loitering munitions and anti-ship cruise missiles. These are all small engines, by the way. China also moved like this. First they produce small engines in high numbers, although small engines have different characteristics in some sense. And as far as larger engines are concerned, you have the Kaveri derivative engine that is meant for the UCAP program, which is also going to see, which has succeeded in high altitude tests in Russia, in a high altitude test facility, which has succeeded in the compressor test facility in Germany, where it was sent for compressor test. By the way, this shows the kind of test facilities we need, by the way, which we have in the missile realm, but we don't have in the jet engine realm. Okay. And now it's going to go to the flying test bed at the Glomov Flight Research Institute. But it has shown
there is a flying testbed program that we're also doing, right?
Yes, we are. It has been, the file has been there forever. So I'll come to that in just 2 minutes, Adi. Just I'll say one thing. So the Kaveri derivative engine is going to be the limited series production. The first runs are going to be done by Godrej Aerospace. Are being done by Godrej Aerospace. Okay. It's for 6 engines. Anyway, so you have this. You have the old Kaveri whose design problems have been fixed over a 20-year period. Yeah. It is a 4th generation engine. You can build that.
Sorry to interrupt you, but that's pretty solid. We're coming up to straight a 4th generation engine. I'm quite proud of that.
Yes, and by the way, in 2006, GE, when it had done its review, had said that they were impressed with this. Yeah. Because the engine was designed well. It's another matter that you didn't. Obviously, it had design problems that had to be fixed and took a long time because you don't have the test facilities. You had to see any setback when you try to make a 4th generation engine or any generation engine will push you back by 5 years if you don't have the requisite test facility, because you will have a waiting period in the foreigners test facility, and they will not give you priority. They don't want you to catch up with them. They'll take your money later when they have set you back sufficiently. But anyway, so that should be integrated with the Tejas test vehicle, and a demonstration should be made over a limited flight envelope. This will send the right message to whoever we need to collaborate with for the 5th generation engine effort, which needs to be launched next year itself, early next year. And that is going to cost 30,000 crores if you want to, for all the test facilities that will need to be built as a development program, and another tranche of money for the final production when it reaches maturity. It will, if you start next year with a commensurate design with a collaborator, you can do it in 10 years time for sure. Because lot of capability exists in islands in India already. There are many companies in India, both large conglomerates and medium-sized companies, who are currently tier 1, tier 2 suppliers to GE, Rolls-Royce, Safran, etc. So we have that manufacturing capabilities also coming up. Okay, lot of it exists at HAL Koraput. GTRE has the design house, the engine design house, has engine designs, has collaborated with Safran in the past. This is the time to strike. This is the time. What is 30 to 50,000 crores? You're building expressways worth 110,000 crores. This will give high returns in the future. The returns will be 6-7 times of that investment. By one measure, just for small engines, do you know the market size that we in India by 2038? Or even earlier by 2035, it's some 61,000 crores just for small engines, small jet engines that will go into loitering munitions, cruise missiles, etc., and UCAVs, UAVs and UCAVs. Just imagine that's just for small engines. We are talking about something like 400,000 crores. That's the kind of import we'll have to do by 2028 if for the large engines. This is an opportunity that the government of India must not miss. Right now, what is happening? We have people from GTRE who have worked on the Kaveri, Manik and other programs who are leaving for GE. So if somebody thinks, in log kya hai, GTRE, no. GTRE is seen as a talent pool by GE, the world leader in jet engine technology. And they're poaching talent from there. Then imagine. So should we let our talent go to waste? I'm not even counting all those people in India who do their PhDs on some area of jet engine technology, whether materials or combustion engineering or design, overall design, who go away to America.
Yeah.
The sheer number of people working in foreign design houses of Indian origin is not funny. If you have an omnibus program, say backed by a national engine commission, you can bring many people back.
Correct.
Even if the salaries are not the highest, they'll be willing to work for India. I know of such people anyway. I've talked to some of them. So ये जो है ना, तो अभी जो स्थिति है अपने आप को कमर कस लेना चाहिए, प्रॉपर इन्वेस्टमेंट करना चाहिए और अपने आप को बैक करना चाहिए. कोई क्विक फिक्स नहीं है टू द चाइनीज प्रॉब्लम, बाय द वे, टू द चाइनीज एयर पावर प्रॉब्लम. देयर इज नो क्विक फिक्स. It all depends on indigenization.
Fantastic, sir. I must say, thank you so much. I'm so glad that I switched the topic because we were talking about something totally different. But I think this requires a lot more balanced thought and a balanced discussion. जैसे आपने करा है. I am really glad that I was able to do that. Thank you so much, Saurav sir. Always a pleasure. Wish you a very happy new year. We are heading into the new year, and I hope the new year is much better than the one that went by.
I hope the budget says something about on the engine front. That is my prayer. And thank you for having me, Aadi. It is always a pleasure to be on your channel.
My pleasure. Namaskar. Jai Hind.
Namaskar. Jai Hind.